Hello everyone, my name is Brigitta. I'm from 11H. Now I will present PowerPoint from Group 6 about gamma rays. First, I will explain definition of gamma rays. Gamma rays, also called gamma radiation, is electronegative wave that come from the excitation and electronic excitation. Gamma was coming from the word of atom core. Gamma rays denoted by the lowercase Greek letter, as you can see, the symbol gamma. And then second is spectrum of electromagnetic wave penetrate Earth atmosphere. As you can see, gamma rays indicate that gamma rays is N, it means no, so gamma rays cannot penetrate the Earth atmosphere. And then the radiation type wavelength. Gamma rays have wavelength less than 10 to the power of minus 12 meters, and the approximate scale of wavelength. Gamma rays enter the atomic nuclei, and the frequency, gamma rays have frequency above 10 to the power of 20 until 10 to the power of 25 Hz. And the temperature of object at which this radiation is the most intense wavelength emitted more than 10 million Kelvin. And then I will explain the relevant figure. First, Anthony Henry Becquerel. In the end of 1890, Becquerel discovered radioactivity. Independently, he covered the uranium salt by using the thick black paper and put it on the photographic plate. And then he put it into the drawer without exposing it to sunlight first. A few days, he found that the photographic plate shows crystal shadow. He speculated that the radiation is stronger than X-ray. And the second relevant figure is that Paul Ulrich Villard. Gamma rays is discovered by French chemist and physicist Paul Ulrich Villard in 1900 was studying the radiation emanating from radium, polonium, and uranium. He finds that gamma rays cannot be deflected by magnetic fields. And the third relevant figures are Ernest Rutherford and Edward Neville da Costa Andrade. In 1914, Ernest Rutherford and Edward Andrade showed that gamma rays were a form of electromagnetic radiation. The wavelengths were similar to those X-ray and are very short. It was Ernest Rutherford who named gamma rays. Rutherford had previously discovered two other types of radioactive decay, which he named alpha and beta rays. And then this is the video mechanism of gamma rays.
The nucleus of radioactive material emits three different types of radiation rays, called alpha, beta, and gamma. Due to the distinct electrical charge characteristics of the alpha, beta, and gamma rays, they can be separated by directing a beam from a radioactive source through a magnetic field. Alpha rays carry particles originating from the nucleus of a radioactive atom. These particles consist of two protons and two neutrons. Essentially, they are positively charged helium atoms stripped of their electrons. The magnet causes these particles in the alpha ray to bend in one direction. Beta rays are a stream of negatively charged electrons. After passing through the magnet, they bend in the opposite direction of the alpha ray. Because electrons of the beta ray have less mass than the protons and neutrons in the alpha ray, the beta ray undergoes a more pronounced bend. Gamma rays are pure energy. Because a gamma ray has neither mass nor charge, it remains unaffected by the magnetic field. The unique characteristics of these three types of radiation affect their capacity to penetrate various materials. Whereas an alpha particle is stopped by a sheet of paper, a beta particle easily passes through paper but is stopped by aluminum. A gamma ray is not impeded by the paper nor aluminum, but its progress can be stopped by lead. The degree to which each of these three forms of radiation penetrate human tissue is the basis for limiting a person's exposure to radioactive material. In terms of the impact of radiation on the human body, alpha particles are generally stopped by the outer layer of skin and pose no real harm to underlying tissue. Beta particles, however, are not stopped by the protective layer of skin and can damage deep sensitive tissue. Gamma rays likewise can penetrate deep into the body and cause harm. This is why it is necessary to wear specialized protective gear when working with radioactive materials. When a neutron is fired at high speed into an atom of uranium, it will split the atom in a process called fission. The stability of the nucleus of an atom is maintained by the balance between the repulsive electrical force among protons and the attractive nuclear forces holding the nucleus together. With uranium, this balance is unstable. Thus, when a fast-moving neutron collides with the nucleus of uranium-235, it is stretched into an elongated shape. This elongated shape tips the balance in favor of the repulsive forces, and the uranium-235 atom splits into fragments of krypton and barium. 3 neutrons are also generated from this powerful release of energy. The 3 forcefully ejected neutrons can each strike an atom of uranium, resulting in the case of an atomic bomb, a catastrophic chain reaction. The nuclear fission process is also the source of energy used to operate nuclear power plants. In a controlled environment, the tremendous heat generated by splitting uranium-235 is used to produce steam that drives turbines to generate electricity.
So, is that the video of mechanism of gamma rays? So, I will explain in Indonesia. Jadi, mekanisme terbentuknya sinar gamma ini terjadi karena berasal dari peluruhan zat radioaktif. Nah, zat radioaktif di sini adalah uranium. Uranium merupakan zat radioaktif dan bersifat tidak stabil. Zat uranium ini mengeluarkan sejumlah energi yang salah satunya energi ini adalah sinar gamma dan energi lainnya adalah sinar alfa dan sinar beta. Tapi di sini sinar gamma ini tidak dapat dibelokkan oleh medan magnet. And last, I will explain about application of gamma rays. First, gamma rays used for radiotherapy to cure cancer, tumor, and other disorders. Second, gamma rays used for kill organism, sterilization, and gamma rays used for fermenting and superior seeds. And the last, gamma rays are used for tracking underground pipeline leaks, and gamma rays are used in vulcanizing natural latex or examining metal defense. And I will explain one of them is that gamma rays used for radiotherapy to cure cancer, tumor, and other disorders. Under normal circumstances, human cells will develop by dividing themselves, as well as cancer cells. But these cancer cells divide too fast and abnormal. Cancer cells occur because of normal cells that mutate. These radiotherapies serve to damage the DNA that regulates the division of cancer cells. Gamma rays will emitted directly on cancer cells to destroy or kill. Normal cells will often by side effect, but only when do the therapy. Okay, that's all the presentation. Thank you for your attention. That's all from me. Thank you. Goodbye.